What's up, guys? Welcome to BUSS1020 online consultation. You might post any of the questions you may have on in the live chat, okay? Oh, nobody is watching. I think I should make an announcement on ED. Yeah, so any questions? Well, it seems like only 4 people is watching, so I think I'm going to send a announcement on ED so that our student will see it, right? So again, please post any questions. Oh, you can't hear me? Sorry, can you now hear me clearly? Ksenia, can you hear me clearly now? Okay, question 16 part B. Well, let's have a look what is question 16 part B, all right? Let me, I just sent a email notification to all students so that hopefully they can all come, okay? Anyway, let me check what is question 16 part B, all right? Question 16, part B. It's in your assignment, quiz 1, practice questions and answers. Question 16, part B. All right, so that's a pretty typical question asking you about the distribution. So it's and their critical values when you are given a probability. So let's see. It says a survey of 20 companies indicated that. Well, I think I'll put it on this side. Okay. Anyway. The average annual bonus for company presidents was 150,000, assuming the population standard deviation is 7,000. So complete the following. So I think this question is mainly talk about the empirical rule or Chebyshev's rule or whatever. So let's see what is given by the Chebyshev's rule. Okay, question 16. Again, let me double check. At most 5.5% of company presidents receive an annual bonus exceeding which value, right? Let me see. I think students have asked me this question before, but I sort of forget. Let me double check. 20 companies. All right. I see. Okay. Yeah, this is not Chebyshev's rule. Okay. Or empirical. Maybe it's empirical rule. But anyway, let's look at this. So it says a survey of 20 companies, right? 20 companies. So the sample size here is 20. And it indicates that the average annual bonus for company presidents was 150,000. Okay. So again, this is actually the sample mean, right? The sample mean. And the population standard deviation is 7,000. So this is the standard deviation, 7,000. And this is the population mean mu. So sigma equals 7,000. Now, let's see. At least 75% of annual bonus for company president is between what? So it says it between 2 standard deviations. Is that right? So again, that interval it's so for question 1, it minus 2 standard deviations up and down. Now it says at most 5.5% of company presidents receive an annual bonus exceeding whatever. So if it is at most 5.5% exceeding a number, for example, now we have any distribution. Okay, we have a distribution here. And it says, maybe 0 shouldn't be here. But anyway, this is any distribution. And it says, at most 5.5% of company president receive an annual bonus exceeding which value? Again, it should be this 5. So for example, it is this value. So on the right-hand side is 5.5%, right? So this basically means if this is the mean, 150K. And if it is somehow symmetric, we can always find the left-hand side probability to be, for example, here is 5.5. So we can always find a symmetric point, a point that's symmetric to this axis, like 150K. So again, when you look at 5.5 and 5.5 in total, so it's going to be 11%, right? So 11% based on Chebyshev's rule. Let me double check Chebyshev's rule. I sort of forget. Chebyshev's rule, Chebyshev theorem. Yeah, it says, all right, the probability of greater than each, how many of the probability is equal to 1 divided by k squared. Is that right? So this 11% equal to 1 over k squared. So we can solve k roughly approximately equal to 3. So that's why we plus 150,000 plus k equal to 3 times the standard deviation, 7,000 in here. Okay, 321, so it's 171,000. So I think you might get confused about this 5.5%, right? It says only 5.5 exceeds which number, right? So if you want to get this upper bound, then there must be a somehow symmetric, maybe not necessarily symmetric, but a lower bound, so that you can calculate the k first, right, from this probability. So the total two tails probability is doubled, it's 11. So k equal to 3. So that's how k is coming from, okay? Yeah, what kind of question will, yes, let's continue on Senia's question. You assume it's not bell shape. Yeah, it's not bell shape. I'm not drawing a bell shape, so we use Chebyshev's rule, okay? Yeah, Kenzie, I suppose so. So just read the question carefully and see whether it is a one-tail probability or two-tail probability. Is that okay? All right. Now, let's look at the question from some Chinese character people, okay? So with a green background. So what kind of question would be asked? Any MCQs? I think in the announcement, it's pretty sure that we don't have multiple choice questions. So the question will be very similar to what you've been practiced in the, for example, tutorials or the sampled question. The difficulty level should be similar, so don't worry too much about it. So any other questions you want to ask? Only 4 watching, isn't it? So you only do 5, it's a two-tail probably. Well, Clara, here's the thing. Well, when we are asked, only 5.5% of all observations, whatever observations, exceeding which value, right? So it's when we look at exceeding, it's a one-tailed concept, right? But Chebyshev's rule only works for two-tailed circumstances. Therefore, we double this probability in order to make it suitable for for Chebyshev's rule. So we have 11% to equal to 1 divided by k squared. Okay, so that's the rationale behind double this. Double this 5.5%. Hopefully you understand this. Yeah. I'm glad you understand it. Well, there can be time lags between I see your message and my voice to be delivered to your place. So yeah, just know it. So do we have to draw a vertical box plot or horizontal? Well, in terms of box plot, it doesn't matter. Both horizontal or vertical should be correct. Okay, don't worry. Oh yeah, sorry, I missed your question. NA is asking in the 2 sigma xy invariance formula for 2 random variables, just x and y's individual ST added together? No, it's not. Sigma xy is the covariance of xy, okay? So sigma xy is actually the covariance between x and y, all right? So you need to find out the covariance first, all right? Okay, any other questions? Oh, it seems like no more questions, right? Is it like only 4 is watching? I think it's my problem. I didn't announce this separately. Yeah, let's see. Kensia Voss is asking, so with the questions about distributions, do we have to write the formula? Yeah, right, yeah, I know what you mean. Write the formula and then calculate using Excel. Yes, you're right. So for example, if you are asked for any binomial random variable with NP, right? And you are asked the probability of x equal to 3. So you need to write down the formula first, like you choose 3 from n and multiply by p to the power of x, which is 3, and 1 minus p, or pi, right? You use pi or p, pi, 1 minus pi to the power of n minus 3. Yeah, this is pi, n pi. Yeah, and then you can write down the Excel result from your Excel calculation, okay? Or we have to plug numbers. All right, well, yes, to be safe, you can do both. But I think it's safer when you plug numbers into the formula, okay? So that the markers can see you really understand this formula, okay? So at least you need to plug in the numbers. But I think to be safe, just write down the formula, plug in the number, and then write down the result you calculated from Excel, okay? So Clara is asking how long we will be streaming. Well, maybe 1 hour. I'll stop at, I will stop receiving any question till 8 p.m. But I think it will go over a little bit after 8 p.m. because there can be some remained questions. Anyway, it seems like if only 4 is watching, oh, this is strange because previously I used to have more than 100 students watching. Maybe it's my problem. I didn't advertise this particularly. So I just make an advertisement in Canvas, in ad. So hopefully it works. So now NA is asking, okay, thanks. Then for the sigma square x and sigma square y, is it the individual variances? Yes, they are. Yeah, they are. You're right. All right, only 11 views. I mean, of my post on ED. Maybe students are all busy with with something else. Anyway, can you do question 27 part 6? Okay, let's see. Question 27 part 6. Question 27 part 6. Question 27 part. Oh my God, you mean B6, right? Okay, let's see. Question 27. I'm now at question 27, part B, VI 6. So use the distribution specified in 1. What is the probability? Let's just see what's the distribution for 10 randomly selected train trips and 1 randomly selected station on each trip. What is the number arriving on time to follow? What assumptions does this rely on and will be satisfied in the situation? So statement translate report 96 on time. So when arriving at the station within 5 minutes of the scheduled time. 10 randomly, 1 randomly selected station. Okay, using distribution specification Y. The probability, okay, no trains on time. At most 9 trains are not on time. All right, so this is about binomial distribution, right? So again, in order to answer this question, maybe you've already let x be, for example, the number of trains that arrives on time within that 10 trains, right? In the sample of 10 trains. 10 trains. Okay, so let x be that number so that x follows a binomial distribution with n equal to 10 and pi equal to, what is that? Arrive on time. So on time proportion is 96%, right? Or on time probability. Now here we are asked to find at most 9 trains are not on time. Okay? At most 9 trains are not on time. It means what? At least what? 1 train is on time. Is that right? So what's the inverse of at most 9 trains are not on time? Okay? At most 9 trains. So that means it includes at most 9 trains. So 9 trains not on time, 8 trains not on time, 7 trains, 6 trains, 5 trains, 3 trains. So at least, at most 9 trains are not on time. Therefore, it's going to be equivalent to at most 1 train. At least 1 train is on time. Is that right? So it's equivalent to at least 1 train is on time. That means we can have 1 train on time. That means 9 trains not on time. So we can also have 2 trains on time. That means 2 trains not on time. 8 trains not on time. And we have 3 trains on time. It means 7 trains not on time. Okay, so they are talking about the same thing. So we are actually asked to calculate at least 1 train is on time. So because we define x to be the train on time, right? The number of trains on time. Therefore, we are actually asking to calculate the probability of x greater or equal to 1. So this is just equal to 1 minus the probability of x less than or equal to 0. Well, less than or equal to 0, nothing less than 0. So it's just equal 0, right? So it's 1 minus, we pick 0 from 10, we do 0.96 to the power of 0 times 0.04 to the power of 10, right? So we have 1 minus, this is 1 times 1, so 0.04 to the power of 10. It's going to be a small number, right? So 1 minus this number. So let me calculate this using Google. So 1 minus 0.04 to the power of 10. It's almost 1, right? Yeah, it's almost 1. Yeah, let me check if I'm right or wrong. Let me check. It's embarrassing if I make it wrong. Question 27. Let me check the answer. Answer. Yes. Oh my God, I'm so good. Yes, it is. It's close to 1. Yes, it's roughly 1. All right. Okay. Yes. Right. Let me see the question from some Chinese character. Okay. So, sir, any suggestions about the probability question? What are the areas that we need to be more careful? Well, everything about probability is important, right? We learn the marginal probability, conditional probability, and joint probability. And we also learn how to use Bayes' theorem. All of those questions are very important. So if you're not happy with any of the topic, you might go back to your slides or go to see your tutorial question, okay? And look at the notes you've taken from your tutorial, all right? Yeah. Are we going to be asked about sampling methods? Well, this is not a question I should answer here because you need to know it, right? But I don't know what's going to happen in your exam, okay? NA is asking, when do we use multiplication rule and addition rule for probability? Well, multiplication rule is when you do things in several steps. And the additional rule is when we use we have different methods of achieving one thing. So correct me if I'm wrong or if I'm not answering your question. But for example, if we are going to count how many ways to get from A to C, okay? So for example, here are the different ways that you can go from A to C, right? So then you're gonna think about how should you count the number, right? So again, you can first choose to go from A to C, or go from A first to B and then to C. So here are two different branches that you can count, right? So from A to C, there is one result, right? So yeah, this is one. And then another alternative way is to go to B first and then go to C. So we need to plus all the possible results here. Now, let's count how many ways we can get from A to B to C. So first of all, from A to B, that's the first step, right? We have two different ways, okay? So that's step one, we get 2. And then from B to C, we have three different ways, right? So we times 3 because this is the different steps, okay? Those are the 2 steps to get from A to C. So you can see when we are dealing with the different approach of doing one thing, we use plus. But when we are separating different steps for achieving one thing, we use plus or multiplication rule. All right. So yeah, so that's when do we use multiplication rule and addition rule for probability, and more particularly. Not more particularly. Well, this example is really specific, right? So if you have any other question, just or follow-up question, just post it here, okay? Now let's see the question from Cassina Werner. Can we be asked for sampling method? Well, again, you can't ask this question, okay? Or I'm not going to answer because it's everything that you learned is possibly being tested. So you need to know it, okay? And I don't know if you are asked in your exam because only the coordinator knows the exact questions, okay? Right. Anything else you want to ask? I still don't get how we can differentiate between these counting rules. Additionally, for contingency tables, how do we know when to multiply? Contingency tables, when to multiply? That's a pretty good question, right? Well, contingency table. Is there any circumstance we need to multiply? Okay, well, let's see. Even if you don't understand what is multiplication rule or additional rule, here are the things you need to know. So for example, for this kind of contingency table, we have let's do a survey regarding, what do you think? Well, let me just write A1 and A2, is that okay? B1 and B2, so whatever it is, we can do it, right? So A1, B1, and if it is the joint probability is 0.2, 0.4, 0.1, and 2, 4, 8. 1. Oh no, it should be 0.3. Sorry, 2, 4, 6. Oh yeah, 0.3. All right. Okay. So anyway, yeah, they add up to 1, right? Okay. So here is how we apply or whatever it is called, maybe a multiplication rule or whatever rule. But the key thing you need to know are the different definition of those probabilities. So first of all, for example, if we want to know the probability of A1, right? If we want to know the probability A1, this is the marginal probability, right? Therefore, we need to add up all the possible circumstances or situations to let A1 to happen. So the first one is this 0.2, right? And then another one is this 0.1. So this means A and B happen together and A1 and B2 happen together. So then this probability is calculated by the probability of A1 and B2 plus the probability of A1 and B1, right? So which is 0.2 plus 0.1, that equals what? 0.3, right? So the marginal probability of A1 is 0.3. So maybe it can be called additional rule, I don't know. And multiplication rule, well, again, let's think about this. If we are asked, what is the probability of B1 given A1 has already happened, right? So given A1 has happened, what is the probability of B1? Therefore, we need to think about, maybe it can be called a multiplication rule, but let's see. B1 given A1, then it is calculated by this circumstance, right? So B1 happened when A1 happened. So B1 happened is here. But given that A1 happened, so that means we only consider this as our sample space. So only A1. Therefore, in all the A1s, only here B1 happens. So it's actually calculated by this 0.2 divided by 0.3, right? So it's calculated by the probability of A1 and B1 divided by the probability of A1, which is the marginal probability of A1. All right, so this is how we calculate the conditional probability. All right, so it's going to be 0.2 divided by 0.3, which is 6.6666%, whatever, 7. All right, okay, so this is a contingency table and how we calculate the probabilities. So when to multiply? I don't really get your question. Sorry, I have a very poor understanding maybe, but hopefully I'm answering your question, okay? So here are the possible ways that to calculate some probabilities, okay? Regarding a contingent table. What about I have a look at your counting rules slides and see what particularly it is talking about. So it's in basic probability PDF slide. And let me find counting rules. Gender counting rules. All right. So basically, you are just asked to find out how many ways to achieve one thing, right? Yes. Then I think in here we pretty much reach that, right? So for example, the total ways from A to C is 1 plus 2 times 3, which is 7, right? Now, if I'm asking what is the probability that a person, for example, this is A to B, this is train, okay? A to B by train, and A to B by bus, and B to C by train, by bus, and by boat, okay? And here, A directly to C is by airplane. Now, if you are asked what is the probability that this person take bus from A to C, right? So here we only have one result, right? So it has A to B, which is bus, and B to C, which is also bus. So it's going to be the probability of taking bus from A to C is going to be 1 times 1, right? Because bus times bus, only one result. And then divide by the total number of ways, right? Which is 7, okay? So the result is 1 on 7, okay? So this is the counting rules. Now, if I say, what is the probability of this person take bus from A to B, right? And regardless of any other choice. So they just take a bus from A to B. Therefore, you need to think about from A to B by bus. However, from B to C, it doesn't specify. So all the three results can be considered as taking a bus, right? So, well, bus times 3. So 3 different results, okay? So those 3 different results all consist taking bus from A to B, right? And then divide by 7. So that's the probability of taking bus from A to B, all right? So this is how we apply multiplication rule and addition rule. Well, let's think about a more complex scenario. Well, I think it's pretty much it, right? Nothing is more complex, right? For example, if there are 2 bus lines, well, yeah, then it's 1 plus 1. Yeah, these 3, okay, you can regard these 3 as 1 plus 1 plus 1. Is that okay? Because from B to C, it doesn't specify. So it's going to be train plus bus plus boat, okay? So it's 1 times 1 plus 1 plus 1. So that is addition rule, and this is multiplication rule, all right? Okay, I don't really know how can I explain this even clearer, but yeah, hopefully you understand what I mean here, okay? Yeah, Kensia is asking, can you show how to plug figures into the standard deviation formula? Well, are you talking about a standard deviation of a probability distribution or a data set? We have 2 different standard deviation formula actually. So first of all is the standard deviation of a data set, okay? So when we have a data set, the standard deviation is calculated by 1 on n minus 1, and we get a sum from I from 1 to n. We take each x value minus x mean square, right? So again, if you do have a data set which has 1, 2, 3, 4, 5, is that okay? So when you plug in this number, you can do it 1 over 4, which is n minus 1. And I from 1 to n, oh sorry, I don't do that, sorry. I'll write down the particular formula, okay? So the mean is 3, right? Obviously the mean is 3. So we're gonna have a 1 minus 3 square plus 2 minus 3 square plus 3 minus 3 square plus 4 minus 3 square plus 5 minus 3 square. Okay, so this is basically how we calculate the standard deviation, or sample standard deviation, I would say. Sample standard deviation, because here's n minus 1. So this is when we're given data, how do we plug in numbers to calculate standard deviation? Now, if we are given any values, okay, random variables. If we are given random variables, oh, sorry, this is not standard. I need to take a square root. Yeah, for standard deviation, you need to take a square root of it because, yeah, inside is a variance. So if we are given random variable, for example, x, random variable x, and it can take different values like 0, 1, 2, all right? And they have different probabilities of each x, which is For example, this is a half, this is a fourth, and another fourth, okay? So the expected value then of x thus becomes 0 times a half plus 1 times a fourth plus 2 times a fourth. So it becomes 3 on 4, right? Or 3/4. So that's expected value. And the standard deviation of x is simply calculated by, again, the square root of the variance, right? And then we have 0 minus its mean, which is 3 on 4 square times its probability plus 1. So 1 minus 3 on 4 square times the probability and plus 2 minus 3 on 4 square times the probability. Okay, so this is how we plug in numbers in the standard deviation formula. But once again, you can always do that in Excel, right? So it shouldn't be a problem in the calculation. Victoria is asking, can you explain hypergeometric distribution? Thank you. All right, no problem. So hypergeometric distribution. First of all, there are several key elements of hypergeometric distribution. First of all, we need to have a finite population, okay? Which means the size of the population is finite, and the population size is defined as n, okay? And within that finite population, we do have different outcomes or different results, but there is only one particular group that we are interested in, okay? So maybe that can be called the interested population, or maybe I would call the number of success, okay? Let's suppose the units that we're interested in can be defined as success, all right? Because that can have some relation to the binomial distribution, right? Number of success in the population is A, okay? Is A. Now, we are going to take a sample of size n, all right? A sample of size small n. And the key thing is that without replacement. So we take it, and then the new sample size becomes n minus 1. If we take another one, it becomes n minus 2. If we take a third one, the new population size becomes n minus 3. Until we take all n of them, the population size becomes n minus n. Okay? So that means we take a sample without replacement. It's not like we take it and we make it back. All right? Without replacement. And therefore, if we define x to be the number of success in this sample, okay, in this sample of size n, then we can say x follows hypergeometric, okay, hypergeometric. I'll make it short, okay, distribution. I think it's good if we can illustrate this, especially the difference between hypergeometric distribution and binomial distribution using a very simple example. Okay? Now, let's suppose we have 10 balls. Now, 10 balls. Too many. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry, 10. And 3 of them are black. Now, let's see what can be a binomial case, okay? So for binomial case, if we have x to be the number of black balls if we take a sample of n with replacement, okay, with replacement, this means maybe in this bag, we take one ball and put it back, all right? Take another ball, put it back. So we repeat that for 5 times, okay? Number of black balls in, what should I say? Number of black balls in 5 trials, right? Or we can call it in a sample of 5 with replacement. Then X follows a binomial distribution, all right? So the number of black balls in 5 trials, or the sample of 5 with replacement, all right? And also for hypergeometric, X is the number of black balls, maybe in a sample of 5 balls, but without replacement, right? Without replacement. All right, so at that time, X follows a hypergeometric distribution, okay? So I think it's quite obvious, right? So the key thing for hypergeometric is that they take a sample without replacement. So it makes a huge difference, because when you do this, if you do it with replacement, every time the probability of having a black ball are the same, right? So that's why we can have binomial distribution. For example, the probability of X equal to, well, 5 balls, like if we have 2 black balls, right? X equal 2, then it becomes how many times we have C5, 2. So we choose 2 balls from the 5 trials, and every time we have the same probability. So it's 0.3 of 3 balls and times 0.7 out of and to the power of 7 balls, right? So this is how we calculate the binomial probability. Now for our hypergeometric, if we take a white ball, for example, and without replacement, we have greater chance or larger chance to get a black ball, right? And if we get a black ball, then we get a smaller chance to get another black ball. So for hypergeometric distribution, it is calculated, for example, X equal 2, right? Still we find that X equal 2. It's actually, we're gonna pick, in total, we pick 10 balls, we pick 5 balls out of 10. So here is the total number of outcomes that can be, okay? How many ways of picking 5 balls out of 10? And then we need to first pick 2 black balls, because we know 2, right? 2 black balls out of the 3 black balls. So we pick 3 out of 2 and multiply the second step, right? Step 2. 7 white ball, we take 3 white, right? So with 7 white balls, we take 3. All right, so that constructs our hypergeometric, what is that? Probability mass function, right? So you may have the function like this, or formula like this. It is big N, small n, right? C big N, small n, and then C, what is that? A, and find out 2, right? Number of interest, which is X, and then multiply by N minus A. So those are the number that you're not interested, and to find out the rest, so N minus X. Is that right? So that's how it comes from, okay? All right. Let's see, Victoria. Yeah, Victoria, are you happy now with my explanation of hypergeometric distribution? All right, now let's look at the question from Clara. Clara is asking, could you demonstrate how to do question 3, please? Question 3.2, message retracted. Got it. Oh, all right. Okay, right. You mean you don't... So do you still need me to clarify question 3? Anyway, chocolate mate. Why is this basically no difference to BUSS 5001? Well, again, QBUS 5001 is a bit faster than BUSS1020, but they are basic statistics. One is for bachelor students, the other is for postgraduate students. Okay, 5001 is for postgraduate students. Clara is asking, does it matter if we write percentage as 0.51 instead of, it doesn't matter, don't worry. And another Chinese character is asking, do you have this recording later? Yes, the recording will be automatically shown in this channel. So if you go back to past live streams, you will see all those recordings. All right. So I think it will be ready in 1 or 2 hours after I finish this session. Okay. NA is asking, what do we need in order to generate mean, standard deviation, standard error in a table automatically from analysis toolpack in Excel? What do we need? What do we need? What do you mean? We need Excel. Well, we need a computer with Excel and also data analysis toolpack. And we also need, I guess you're asking, we will need the data, right? We need the raw data in order to perform that basic statistical summaries. Otherwise, if we don't have the data, how can we do the analysis, right? So we need the data to use that descriptive summaries, all right? Okay, any other questions? We still have 6 minutes left. NA asking only the raw data? Yes. Otherwise, I mean, if we don't give Excel raw data, how can it calculate the mean, right? Like even as a person, if you are not given raw data, how can you calculate average, right? So we need data to perform those calculations. Okay. I know what you are asking, NA. Yeah. So when we are given data, we can use mean and standard deviation, but also if we are given probability distribution, I guess that's what you want to ask, right? If we are given probability distribution, like where is it? I just did a demonstration. Yeah, when you are given a probability distribution like this, right? Well, it's still raw data, but that is called a random variable or probability distribution data. So we cannot use Excel to directly find the mean or expected value or the standard deviation. That's because the weight are not equal. Because in those things, we basically take an average, right, of all observations. Because we assume, not we assume, but the likelihood of each data to be observed are equivalent, so that we can just add them all together and divide by 5 to calculate the average, right? But here, the weight of their occurrence are different, so we can no longer add them all together and divide by 3. But now we need to do the weighted average and also the weighted standard deviation, okay? So I guess that's what you are going to ask, all right? Sorry if I was offensive, but I didn't mean to, okay? I just didn't get your idea, but now I think you might just want to ask about this, okay? Now, let's look at the Chinese characters question. Do you have any graphs to draw in exam? That's spending so much time. Well, maybe a graph, even if you are asked a graph, it will be a rough graph, okay? You don't need to be that precise, like you use a ruler, right? For example, this is a ruler. You don't need to do like this, okay? You don't need to do like that. You can simply do, right, blah, 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 okay? Just give a rough idea, okay? But maybe if you're asked to label something correctly, for example, you're asked to label a distribution and label the mean, and you need to write down this mean is 0.3, whatever, right? You need to do the correct labeling, okay? But other than that, we don't require you to draft a very, very beautiful picture, okay? Just draft it. NA. Because in StatCrunch, we can immediately generate summary statistics. So in Excel, we just click histogram function instead of do that. Requiring raw data given to generate summary statistics. No, it's not histogram. Well, NA, we need to use summary statistics or descriptive statistics in data analysis. Okay? Yeah. So, well, basically, if you want to get a summary statistics, you go data analysis. And then you go descriptive statistics. Histogram is for histogram only, okay? And once again, you need to know StatCrunch is only a kind of tool designed by the publisher, and it's not commonly used. So in your work, in your future work, all you will have access is Excel. You will never access StatCrunch, okay? So you need to learn how to do everything on Excel. That's why we focus on Excel in our tutorials, right? Okay, any other questions before we call it a day? Now we still have 2 minutes to go before you can pose a question. Do we actually need to learn StatCrunch? I think there is only one scenario that, well, first of all, StatCrunch is like a game, right? I mean, it's nothing to learn in StatCrunch because they are so straightforward, right? For example, if you do want a summary statistic, you just click summary statistic, right? If you want histogram, you click on histogram. So, I mean, you still need to know StatCrunch for this course. And maybe in future, in your assignment or wherever, you may need to do some calculations using StatCrunch. But again, our main focus should be on Excel, okay? NA is saying, an IC, thank you. What do we put for K largest and K smallest in descriptive statistics? If you do need them, you can put them, but if you don't need the K largest and K smallest, you just leave them blank, okay? If you want the mean variance or whatever, you can just check the summary statistics and you'll be okay to go, okay? So you only need the summary statistics and then you click on OK and it will work. All right. Any other questions? How do we know when do we need K? If you want to calculate what is the K largest and the K smallest, for example, I have 100 data, okay? 10,000 data. I just want to know what is the 536th largest value. Okay, then you just input 536 as K as the largest or smallest, okay? Well, maybe this is not good, but for example, I just want to know the top 100 and the bottom 100 observations, okay? Then you just, and what are those values roughly to be? Then you need to input 100. So when you need K largest or K smallest, then you input K, right? Otherwise, you don't need to input K. So it depends on what do you really need from the Excel output, all right? Okay. I think time is pretty much up, but I know the day after tomorrow is going to be your exam. So again, don't be panic, okay? So case to make summary for the 100. No, NA. Well, this 100 is a number that I randomly think. So K, you assign K a value. For example, you input 100 in K in this 10,000 data, okay? Then it will give you the 100th largest and 100th smallest, okay? So that's what I'm talking about here, okay? So it doesn't only work for the 100 observation only. So when you need to know For example, I have the exam marks of 10,000 scores. So I want to know what is the top 100 students like cut down mark, right? So which number cut down the top 100 students and which number cut down the bottom 100 students, right? Then I input 100 as k in the kth largest and kth smallest, so that you're gonna know which number is the maybe you get, for example, the top 100 students maybe get 83, right? So that's what Excel will tell you. Maybe 83 marks is that cut down number, all right? So when you want to know something like that, you assign k values to them. Otherwise, you don't need to input k, all right? Okay, yeah, I'm glad that you understand, okay? All right, any other questions? Let me see how many of students have viewed my announcement. Tony's online consultation is on live now. Yeah. Your Gmail account. Okay, 31 students look at my announcement on ED. Yeah, I don't think the students usually check their emails very often. Anyway, that's so much for today's live streaming. And thank you very much for coming to this tutorial, this consultation. And once again, my usual consultation time is from 1:30 p.m., right? 1:30 p.m. to 2:30 p.m. On Friday or tomorrow. So you can just come by and come to see me if you have any further questions, okay? All right, that's all for today's consultation. Thank you very much for watching, and wish you the best luck in your exam, okay? Yeah. All right, I'll see you in the next tutorial. Bye bye.